Okay, so a contingency table. All right. So it's basically going to be a table that has, we'll say, a table with two variables, one for the rows and one for the columns. Okay, and so again, here's an example of a contingency table. And we have the class variable as our columns and the survival variable as our rows. And then everything that I have in purple here, because they lie in the margins, that's going to be the marginal distribution. And it's basically going to be the total counts or total percentages. You typically wouldn't have both. I just included both to show you that it can be either. So you would either have exactly the first total, which would just be the counts like that, or you could replace all those with the percents. You wouldn't have these blank cells there like that. But if it asks for marginal distribution, either one is fine. So I'm just going to say, be careful, all right? So again, when it says percent of what, this was the box that Bodhi read, percent of what, right, on page 20. We need to decipher the English language because it could be asking for the row percent. It could be asking for the column percent. Or it could be asking for the overall table percent, or the overall total percent. Alright, so independent. Alright. And so we'll say if the distribution of one variable is the same for all categories of another. So if that's true, we'll say that those variables are independent of each other and that there is no association between them. Okay, so again, we'll learn how to formally do this, but for now, you can just look at a table, and if the percentages look roughly the same all the way across the categories, they're independent. Or if you're looking at some sort of chart, like a bar chart, and all the bars are the same size, they're all the same size, it's going to be independent. Okay? If it's the same. Independent is same. Okay? Alright? For example, like we just said, this right here, are all of these bars the same, roughly? No. So this means that ticket class and survival were dependent. There was a relationship there, which in this case was not really good for some of those people that were in second, third, and crew. Not good for them, right? If it was independent, everybody would have the same chance at surviving, and it would have been a little fair, I guess. Okay. Is there an association? Okay, so you say that there's no association, but it's dependent?
No, there is an association. I don't know.
I don't think there's.
It's gotta be
Just an
Okay.
association.
Yeah.
If the bars are the same, then we would say that it's independent. Are they the same? No. So this is going to imply that it's dependent. Okay? So also, if it's independent, then it would mean that there is no association. So if it's dependent,
What do you mean if all the bars are the same?
well, in this case, we would expect these to be the same, these to be the same, and these to be the same.
How would that show independent?
Because it would be saying that it doesn't matter what your sex is. Let's just pretend, let me just average these out. Let's just slap this here. Say these were identical at like 45%, and say these were identical at like 20%. And what is that, 65? So, right. So then this would have to be 25? No, 35? So it's a little off, but whatever. Okay. Pretend they were equal all the way across the board. That would mean it doesn't matter what your gender is or your sex is. It just means that 45% of people like to watch football, boy or girl. And 20% of people like to watch commercials, boy or girl. And 35% like to not watch at all. And so that would be implying that they are independent, because there's no association between your sex and your preference of what you like to watch.
We're not.
Okay? But because they're not the same, because they're all different, I mean, these ones are close, but these ones are drastically different, right? Clearly, way more men like to actually watch the game, and way more women like to actually watch commercials. That means there's an association between your gender and your preference of what you like to watch. And if there's an association, that means there is a dependence as well. So these are not independent, they are dependent upon each other. Does that help? So if the bar graphs are the same, it's independent. Or if you're looking at a contingency table, if the percentages are the same, it's independent. And if it is independent, association or no association? No association. So this is going to be the same, let me just add this. This is the same as there is no association between the two variables. Okay? And the opposite would be true. If they're dependent, then there is some sort of association between them. So this will be the last thing that we do here. So what percent of females are brown-eyed? Okay, here's where we're getting some practice at. Is it asking about the row percent? Is it asking about the column percent or the table percent? So what percent of females are brown-eyed?
Because it's asking for female.
It's asking for females first. That's the condition. Condition is female. So we need to restrict our view to the row view of only females. And once we've restricted it to the row view, now we need to find brown-eyed out of the total, which is going to be 16 out of 32 or 50%. So number one's 50%. Number two, what percent of brown-eyed students are female? This is worded backwards of the first one. So
16 over 36. Yeah. Column.
it's a column view, so we need to restrict our view to only brown-eyed students and then look specifically at females. So 16 out of 36, which as a percent is 44%. 0.4%. Number 3, what percent of students are brown-eyed females?
All students.
What kind of percent? Row, column, or table?
Table.
Table. We need to go to the overall total.
25%.
So we need to go 16 out of 64, which should be 25%. Number 4, what's the distribution of eye color? Okay. When it's asking what is the distribution and now it's giving you a specific variable, that's your condition. This is a conditional distribution. In other words, it's asking you to restrict your view, and since it's already given us the totals, it wants all the percents. So it wants you to look at eye color. So are we doing row or are we doing column? Eye color is going to be column. We're looking at all the columns. Eye color, eye color, eye color. And it wants the conditional distribution. So it wants the percentages of all of those. So it wants blue is 10 out of 64. So 10 out of 64 is 15.625. So it's 15.6%. And so you can add that below the total for the column. And then 36 out of 64 for brown. That's 56.2, or yeah, 0.25. So we'll round to 3, I guess. And then green, hazel, other is 18 out of 64, 28.125, 28.1, whatever. Okay? That is the distribution of eye color. So notice we didn't care about male or female at all. We were just saying out of the total, this was the percent for each one. That's how it was distributed across the population. Okay? Or I guess across that sample.
And those should all add to 100, right? Or roughly because they're rounded.
Yes, exactly. What's the conditional distribution of eye color for the males? So now it's looking for the males specifically.
Row. So 6 out of 3. What do you have? Right. So wants to know just for males.
Right. Exactly. See, I still have to stop and think about it myself. It's just looking for males. That's another condition. We are restricting to only looking at males.
Okay.
Only looking at males. We don't care about females now. So now we have to do all the percentages. So what do I have to do? 6 out of 32 for blue. Write that percent. 20 out of 32 for brown. Write that percent. And then 6 out of 32 for green, hazel, other. I'm going fast because we're short on time. Compare the percent who are female among the blue-eyed students to the percent of all students who are female.
So 10 out of a female total?
Percent who are female among blue-eyed. So
4.
Female among blue-eyed, which is
40%.
4 out of 10 or 40%. Compare that to the percent of all students who are female. Well, 32.
So 32 divided by
64, so 50% are female. Okay? So does it seem that eye color and sex are independent? Okay? No? How come no, Bodie? Yeah, do the
not the
percent,
same for all the categories.
do the percentages or the counts, I get that, do the percentages seem similar across all the categories based on sex? No, they're different. They're kind of noticeably different, especially in the green, hazel, other.
Yeah.
So according to this, it appears that there is some association or dependence between your eye color and your sex. There might be a relationship there, which is interesting. Yes. Hey, Dominic.
Someone beating home, Ben Homer.
Well, here's